Okay, year 8. So what we're doing today, we're just carrying on our work on the topic of waves and electricity. But today we're really going to be focusing on light waves. Now, there's loads of these around at the minute, rainbows. But I want you to take 30 seconds. What actually creates a rainbow? Why can we see them? Where do they come from? Okay, so just pause and give yourself a few seconds just to think about it. Okay, now I'm not going to ask you for the answer and I'm not going to ask you to write it down, but hopefully you've come up with some ideas why we can see rainbows. Now, by the end of this session, you're going to understand why objects are different colours, and it's not just because we paint them. You're going to know that light or white light is a mixture of colours, and you're going to have a go at making your own rainbow. You're going to be able to explain how you can separate white light out into the spectrum of colours that we can see. And some of you are going to be able to have a go at predicting the appearance of different objects or different coloured objects and different coloured lights. Now, on this slide, you'll see that I've got 3 filters, a blue, a green and a red. Now, as the light passes through the blue filter, what colour do you think will come out the other side? The same with the green, same with the red. So, as you can see, light goes through a blue filter, we get blue light out the other side. Goes through a green filter, we get green light out. Goes through a red filter, we get red out. But why is this the case? Okay, now filters, you'll see them used in theatres to create different coloured light. Okay, now these filters simply absorb the different colours. So the blue filter absorbs all of the other colours contained in light apart from blue. Green, every other colour apart from green, and red, every colour apart from red. Why? What's its use? Well, we'll find out. Now, Sunita puts on a pair of special glasses shown below. These glasses have coloured filters in them. Okay, one lens is green, one is red, in a nice fashionable cardboard frame there. Now, many years ago, probably before any of you were about, this is how we got to see 3D films. But that's a different story. Now, I want you to read this question or listen to the question and then pause the video so you can write down your answer. So Sunita looks at a lamp through the green filter. The lamp gives out white light, but it appears to be green. Explain how this is possible. Okay, so pause the video here and just in a couple of minutes, write down your answer. I'm looking for 2 reasons. Okay, now hopefully you have got your answer down and I'm going to get you to mark it. So, if you had mentioned that white light is a mixture of colours or that white light contains green, you could have a mark. The green light passes through, all the other colours are absorbed or filtered out, or only the green light passes through, you get another mark. So, well done. Now, I'm going to show you this video. It's quite a cool video, actually. You might recognise the gentleman in it as Brian Cox, or Professor Brian Cox, I should say. And before he started showing off his intellectual prowess, he was also the lead singer of a band. Bonus points if you can let me know. So, here we go.
Newton was born in 1642 into an England that was a country in transition. And that was the start of the English Civil War. It was a country where they were still hunting for witches, but also it was a country where science, where rational thought, where reason were beginning to flower. Now, at the time, one of the great questions was about the nature of light. It was known that if you take a prism and shine sunlight through it, then it splits that sunlight into all the colours of the rainbow. The question was, why? Now, the prevailing scientific view was that sunlight must be perfect. This dated all the way back to Aristotle and the ancient Greeks. How could something that comes from the heavens be anything other than perfect? The common explanation for the appearance of the colours was that they were impurities added by the prism to the pure white light. Newton thought that the colours were already present in the white sunlight. But what set Newton apart was the fact that he devised and performed an experiment to test his hypothesis. First, he made a rainbow by shining white light through a prism. Then, and here's the genius, he introduced a slit into that rainbow beam, and that allowed him to isolate a particular colour of light and shine that into a second prism. Then he looked for the deflection of the coloured light onto his wall. You can see that over there. Now, look what happens when I move the red light across the slit to the green light. On the wall, what you see is green light into the prism equals green light out. Now, that implies that the colours themselves are pure. The prism is not adding or subtracting anything. That means that Newton's hypothesis was shown to be correct. The colours themselves are the basic building blocks of light, and white light is made up of all those individual colours. That's genius.
Okay, so that's pretty cool. Now, not quite as professional, but this is where you get to have a go at creating your own spectrum. And I'm going to give you a quick idea on how to do it. Here we go.
Okay, Year 8. So we're carrying on looking at waves. Now, we've spoken about the two main types of waves that we'll encounter, and that's longitudinal and transverse. And we've also decided that light tends to be a transverse wave, whereas sound is a longitudinal wave. Now, looking at light in a little bit more detail, I've spoken briefly about colour in the past, but how do we actually see the different colours of the spectrum? Now, colours are all on the electromagnetic spectrum, and obviously we are able to see different colours due to the fact that we have specialised cells in the back of our eyes called cone cells, and these are able to pick up different wavelengths that represent the different colours that we can see. So although we can see colours because the light is reflected off of objects and it isn't absorbed, so that is the colour we see, light is refracted as it moves through objects, okay, and these light waves that we see are bent at different angles because of their wavelengths. Now, obviously we've all seen a rainbow. Okay, we are able to see the colours of the rainbow because the light is moving through a liquid, which as we know is denser than air, so it causes the light to refract, which causes it to separate, allowing us to see the different colours. Now, on the electromagnetic spectrum, there are colours that we are unable to see. We are biologically limited. Our eyes just physically cannot pick up the wavelengths. So an example of this is ultraviolet. It has the shortest wavelength, whereas red has the longest. So infrared has a very long wavelength, which is outside of our vision range. Now, in order for us to see this, we're going to have a go at creating our own rainbow effectively. And it's very, very simple. All you need is a glass container that you can put some water in. I've just used an old jam jar. You could use a glass, That's fine. And what you need to do is half fill it, get some white paper, and if you hold it in sunlight, oh, there we go. It may take a bit of fiddling to get the correct angle, but you will see you are able to create your own rainbow or spectrum of colour. You can sort of see it here. You've got the red, yellow, green, blue moving up towards the ultraviolet on this left-hand side of it. And as I said, this is only visible due to the different wavelengths of light. Okay, so different colours have different wavelengths. We are able to see the different wavelengths through refraction because they travel at different frequencies or speeds. They go through the water. Can anyone remember what it's called? Tell me, let me know. Okay, it refracts, it bends towards the normal, and because it has a different wavelength, it bends at varying angles, so it spreads the light out into separate colours. Okay, so year 8, give it a go. Go get a jar or a glass, half fill it with water. You don't have to use the sun, you can use a torch. Shine it through it, use refraction to create your own rainbow. Give it a go.
Okay guys, so hopefully you'll have a go at that. But we're now just going to have a look at a little bit of literacy within science. So I want you to write down the definition for these 3 words: disperse, spectrum, and refract. When you've done that, I want you to have a go at the 2 questions below. How does frequency affect the amount of refraction? And what happens if you line 2 prisms up so light passes through both? And have a go at explaining why. Okay, pause the video and off you go. Okay, hopefully you've all got an answer. So disperse means the different waves become spread out. Spectrum is a collection of coloured bands, and refract is when waves are bent as they move through glass. Okay, frequency affects the amount of refraction because the higher the frequency, the greater the amount of refraction that occurs. And what happens when you line up 2 prisms so light can pass through both? You get white light again, okay? And basically it's because refraction in the opposite direction would occur, so all the waves would recombine. Now, primary colours, your red, your green and your blue. Pretty much the building blocks of colour. These 3 colours you can make any other colour out of. Okay, so if you've got those 3, you can pretty much make anything you like. And it doesn't always turn brown like in art. Now, an example of this is this. Anyone got an idea of what we're looking at here? Okay, it's actually a digital screen. If you look at your TV screen, your computer monitor, your phone through a microscope or a magnifying glass, you will see lots and lots of blocks of these 3 colours: your blue, your yellow, your red. So your blue, your green, your red. Okay, now the reason for this is these 3 colours are the primary colours, and you can make any colour you want out of it. Okay, now each of these 3 blocks of colour is a pixel. So there's one, there's another, there's another, there's another. And each of these receives a signal to basically light up these 3 colours in a specific way to create a certain colour. You put them all together and you create your image. Pretty cool. You may see this in art where a picture is made up of lots and lots of tiny dots. It's called Pointillism. Same sort of principle to create a bigger image. Now, here we've got a little tree frog. And I would like you to try and just write a paragraph explaining why this frog looks red and black. So pause the video and have a go. Okay, very, very simply, white light, as we now know, is made up of all of the other colours. It hits the frog. Okay, the frog skin absorbs the green and the blue light, and the red light is reflected off, which is why we see red. Where the black spots are, all of the colours are absorbed, including the red, which is why we only see black. So there you go. Now, here's a link to Bite Size. If you just want to stretch yourselves, go a little bit further. It's actually really interesting just to have a read through. So please do have a look at it. And I hope that this will help you to answer number 5 in book 2, or section 5 in book 2, and a varying array of questions in the first booklet. Okay, have fun.